Hey everybody, this is Sean again. As the last time I did get interrupted, although the video did end up going almost 40 minutes. I was expecting like 20, 25. It happens, unfortunately. But as you can tell, for instructional videos, they can go long, especially when you're doing explanations, questions, what the answers are, possibilities are, and stuff. I mean, giving you the answers. And I am sorry that the comments have not been on. I put it under for kid friendly. I'm going to take that off. So apparently that's probably one of the problems I was having. So no comments available. So yeah, it happens unfortunately. Did not realize it. So I'm going to go on from there. As I was finishing up, I was going into tools. So let's go ahead and click over onto the tools section here. Now, this finishes out the questions. It's 30 through 46, so it's 16 questions. Now it says, refer to the plastic weld replicas as well as the book of standards. See bevel edge G0 on the plate replica. Will this angle of bevel be acceptable to use with D1 of the BOD single bevel group? Okay, so I will come over here, put my pipe out of the way. This is the replica that you get. So you have G6, G0. So what it wants to know is zero replica. Would this angle bevel be acceptable to use with document 1 book of specs? So let's go ahead and get our book book of documents. It's the bod. G0. Let's go ahead and take a look at it here. As I have fun with these. So we can go across with our protractor, and you can firm it up just a little bit as it is on a screw. So we can go across, go boom, tighten, double check. It is like 63 from 90, so the angle is actually too small. The angle, the questions, the possible answers is, yes, the angle of the bevel is about 20 degrees. Yes, the bevel angle is between 45 and 65 degrees. No, the angle of bevel is too small. No, the angle is too great. Yes, the bevel angle is between 35 and 40 degrees. Well, the answer is no, the angle of the bevel is too small. Now it says, if you measure the G0 angle of bevel with a protractor, you will read about 70 degrees. As well as learn in module 7 and 9, subtract the reading 90 to get the bevel. So in this case, we get 20 degrees. And with me, I'm looking at going, okay, which one? And there's just a tiny, I don't know if you can see that, just a tiny little groove right there, and that's what you read. I wish they would have done white or black on that. That is hard to read. So I think I'm going to end up doing that a little bit later. Put a black mark on it so I can actually read it. Because if the class, where I'm taking the test at is a United Steelworkers out of Tequila, Washington, which is out by Seattle. I'm in Lewiston, Idaho. So I go to Pullman, take a flight to Seattle. I'll stay at the airport there. Then next morning, get up, study, take my test at about a little after 3 o'clock in the afternoon. because I guess they have another 1 or 2 tests before that. So I guess there's going to be a lot of people. As I missed the one for Father's Day in Spokane, I was like, I'm going to be out of town. I can't make that one. My brother just moved into a new place and went to basically help Chris in the house. They were only there for like 2 or 3 weeks before Father's Day. So, nice looking house. Not my style, but nice looking house. So, go back to the question here. So, we get 20 degrees per WPS of CAW-1. The lowest allowable angle of bevel for a single bevel groove joint is 35 degrees. So, the answer is C. Next. Okay. Is the undercut on G1 of the plate replica acceptable if using structural steel criteria for a cynically loaded non-tubular connection? Assume it is a primary member and the weld is transverse to tensile stress under design loads. Our possible answers are: no, the undercut exceeds 1/32. No, the undercut exceeds 0.01 inches. Yes, the undercut is less than 1/32. Yes, the undercut is less than a 16th. Yes, the undercut is less than 0.01 inches. So we look at G1. I'm switching between screens, so I'm sorry this kind of takes a little bit longer. G1 is this weld right here. Right. So if you go right across, you see a little undercut right there. It's not much. That undercut is roughly 0.01 inches. Now, if you really want to get technical, you go over here to your VWAC gauge, loosen up the thumbnail just a little bit. Come across, make sure it's level, push down where it is at. I can feel that groove just a little bit. Twist. A little bit. It reads a little less than a 32nd of an inch. So, the variable plate is used in structural steel criteria to load assume as primary. Seeing how the undercut exceeds 0.01 inches. Now, per table 1, we'll go over to our book of specs here to table 1. Where's table 1? Here we go, table 1. It's in clause 2. Workmanship, visual, structural steel. Now, if I go down to table 1 to boss row 7B, it says, in primary members, undercut shall be no more than 0.01 inches deep when the weld is transverse to the tensile test. Under any design floating condition, undercut shall be no more than 1/32 inch deep for all other cases. So, if it is under a cynically loaded non-tubular connection or tubular on all loads, it has to be less than 0.01 inches. So something like that, you're gonna want some micron reader, something like that. That's electronic, good for measuring distances. So if you know your weld crown is like say 1/8 of an inch, you put that over, says 0.161. You know that second one is the out of placement piece. I think that's how. I just passed that page too. Hey, if it says, yeah. Oh, okay. Alright, here it is. If it would have said 2.61, it would have been out. Like I said, I just passed that piece of paper. I had to find the right number I was looking for. No, I was right. Yeah, it's 162. Yeah, it's 1.162. But either way, it's a fractional of an inch. Just fractionalize. So, yes. 7B does not allow undercut over 1.01 inch depth for this type of weld. The undercut measured almost 1/32 and exceeds the 0.1. Now, if I showed you where this was, let's see if I can get you guys a good picture of it. Oh, wrong way. Oh, there we go. If you can count the... Oh, no, I moved it. I'm sorry. That first notch right there is that 32nd. Above 0. Not below it, above it. It was almost touching that 32nd. Right there. Not quite. So that's split. So it's B. No, the undercut exceeds 0.01 inches. Next. Come on down. What is the most accurate assessment of the G3 weld plate replica using structural steel acceptance criteria? Assume it is a CJP or a complete joint. Oh shoot! I just drew a blank. I got my book. It's actually a question on the test too. Not this one. It's gonna be A or C. That's gonna be on. I think it's general knowledge. It's gonna be a question on the test. The 5 possible answers are reinforcement bad, repair good, overlap bad. Reinforcement good, repair bad, overlap good. Reinforcement bad, repair good, overlap good. Reinforcement good, repair bad, overlap bad. Reinforcement bad, repair good, repair bad, overlap acceptable. So we go to G3. If you look back in the video, you see that's the one that has the big old gash in it. So it says plate replica using structural steel acceptance criteria. What's the best assessment of it? Well, you look at the reinforcement. It has that big old gouge in it. If the gouge was in the metal itself, it has a possibility of being acceptable as long as it wasn't deep. This goes into the base metal, through the weld, everything. It literally cuts it right off. So, right there, the reinforcement is unacceptable. The repair is unacceptable, as it looks like they try to come the other way. I'm looking at... No, they did not try to come the other way. But the repair with the gouge, reinforcement was bad. I mean, if you were on a professional project with pipe welding, whatever, you'd be fired for this. Overlap, acceptable. Yeah, the overlap, no gout, no undercut. The height is good, which is sitting right at an 1/8 to 3/32. So yeah, that is good. So it's going to be E. Reinforcement unacceptable, repair unacceptable, overlap acceptable. Explanation is reinforcement measures over 1/16 of an inch, which the maximum allowable tolerance for a plate that measures less than 1 inch. Alright, so it's a 1/16 of an inch. The repair is unacceptable, section 2.2.5 of the BOS, since the base metal was damaged, hence that big old gouge in it. There is no clear observable overlap, so this is considered acceptable. So, Reinforcement, 1/8 inch, no good. Because it's under that 1 inch. So you get to learn something, I get to learn something. Yay, we learn. Yes, I am a cornball. Review the G4 weld on the test plate replica. Does the weld meet structural steel acceptance criteria? Assume the plate is 1.25 inches thick and that this is for a CJP statically loaded non-tubular connection. Our answers, possibilities are: yes, the termination location is acceptable. No, the termination location isn't acceptable. No, joint is not completely filled. Yes, the undercut is acceptable. No, the reinforcement is unacceptable. So we have a few options, which makes it so much more fun. Just give me the answer. No. Then everybody would be a welding inspector, wouldn't they? We have no welders. So looking at the G4, which is this one right here with the little dot in the middle, which would be where a weld ended. So yes, the termination's location is acceptable. No, it's right in the middle of 2 welds. No, it's not. So no, the termination location is not acceptable. Oh, no, it's not acceptable. And yes, the termination is acceptable. No, so it's neither one of those because it location blows. Let's put it that way. C, no, the joint is not completely filled. If you see that, you see the joint is not completely filled. There's a little undercut plus right where the weld ended. It's like they went, here's this part of the weld, here's this part of the weld. But it looks like actually more like it went like this. And you didn't feel the middle. Because if you go this way, you're fine. Go this way, you're fine because you're following your pattern. But if you go opposite, you better fill that hole up. You have D. Yes, the undercut is acceptable. No, it's not. No, the reinforcement is unacceptable. Now, by the looks of it, no, it is not acceptable. So, let's go ahead and look at the explanation. The flaw in this weld is the joint is not completely filled, hence the dot in the middle, which does not make a CJP. Weld is violates line 3 of table 1 in the BOS. The termination location at the corner of the weld, but terminations only matter for fillet welds. The reinforcement is less than the maximum allowable 1/8 inch per table 3, and there's no undercut in excess of 1/16 of an inch. So the answer is no. Joint is not completely filled. And my wife is home, so you'll see her popping in here in a moment, as I will just pause here for a moment. Hi. About 10 questions to go.
Okay.
Just, anything good?
Well, I think we got the Christmas list.
Oh,
but apparently your name is Scene now.
no, it's the way to say Sean. I know, seems weird, but yeah.
It's the Irish way, which you are not. See,
That's been in my truck for the last week. I told you about it.
You also said you forgot to pick it up.
Alright, fine. It's been in truck for a week. Last time I was over there.
Christmas list.
Yeah, just Christmas. We have a Christmas list from Boise. We also do one with Indiana. So they're all in-laws.
And they spelled your name wrong.
Well, I do have Irish in me.
Well, get him out. It's my turn.
Well, you know the red hair in my beard here is
They misspelled Steven's name too. They did it with a PH.
Oh, Jimmy Christmas. It's not Steven, it's Stefan.
That's Stefan.
Close enough. No. Anyway, we'll go to number 34 here. What is the best assessment of bend test B3 of the bend test specimen replica used in pressure piping acceptance criteria? Assume no evidence of lack of fusion, slag inclusions, or other. In other words, no technically visible discontinuities. So I will go to, where's my bend piece? Did I leave my bend piece over there?
You what?
It's a piece of plastic that looks like it's bent in half. In the chair, in the box, or anything? And in the blue chair there?
This one?
That would be it. Thank you much. I thought I grabbed it. Oh, B3. So I will show you what this one looks like. It's just bent pieces. As you can tell, it goes close and in, as this one's further out than this one. So there isn't really any questions about how far the bend is. I think there's one question that is given. That's it. So it's not a lot. But here is what B3, the front of B looks like. See, there are the numbers. I will turn that around for you. So, yep. There you go. So you get an idea of it. So let's go ahead and go to B3. If the replica using pressure piping acceptance criteria. So we look at it. We see where the clamp was, which that does not void anything. We look at it. We see a crack right here. See an occlusion right here. Let's see what we have here. The 5 possible answers are: the bend test is acceptable since the discontinuity matrix is less than 1/4 of an inch. The bend test is rejected since the discontinuity, I can't say it right today, matrix over 1/4 of an inch. So we have less than and over. The bend test is rejectable as the discontinuity measures over 1/8 of an inch. D, the bend test is void and a replacement bend test from the same weldment should be examined. Then we have E, bend test is acceptable since the discontinuity occurs at the corner. What I believe they are mostly looking at is this little piece right here. Just that little crack that's right in the, as you bend it, it's right there. So let's go ahead and take a look at what the explanation is. First, section 5.4.2.3.2 is, let me get to 5. 5, 4, 5, 4, 5, 4. There's 3. There's 5.4.2.3.2. Oh, I went too far. Like, whoopsie. Because it's, the answer is the bend test is void and is replaced bend test from the same weldment to be examined. So the discontinuity on the corner of the specimen is not considered. The specimen is essentially tossed out and another one specimen must be tested and examined instead. So number on the parentheses of number 2 here is open discontinuities occur on the corners of the specimen during test shall not be considered a shall not be considered and a replacement test specimen from the original weldment shall be tested unless the definite evidence that the open discontinuities result from lack of fusion, slag inclusions, or other discontinuities. So if you look at assume no evidence of lack of fusion, slag inclusions, or other internal discontinuities. So essentially what they're saying is that the weld itself broke. It could have just been stressed. If anybody has ever seen a weld bend, you can look at it and get a pretty good idea of what happened, because you can see slag, but if you see a weld that just breaks, you just see metal. So yes, the bend test is void and a replacement. 35. What is the best assessment of the B2 bend specimen using pipeline acceptance criteria? Assume the wall thickness is 3/8 of an inch. So we go to number 2. Number 2, we see where the grips were, but you see this big old divot right in the weld. I'm sure you can see that right there, a big old divot. To me, it looks like someone just took a nail, went ping, and just kind of filed the roughness off. And I was like, oh well. The possible answers are: the bend test is not considered and a replacement is used instead. The bend test is rejectable due to the imperfection present. Now, just because you have an imperfection does not mean it is void. It's the size of the void is what makes it bad. So on a corner, if that crack is like 1/8 of an inch, you're going to pass. If you have a chunk right in the middle of it, and as long as it doesn't reach basically over like 1/8 of an inch, you're fine. But it's when it gets beyond that, so you're seeing cracks, lack of fusion, slag inclusion, stuff like that. So, bad stuff. So B is the bend test is rejectable due to the imperfection present. 3, the bend test is acceptable due to imperfection being less than 3/16 of an inch. 4, the bend test is acceptable due to the imperfection being 1/8 inch or less. And E, or 5, the bend test is rejectable due to the imperfection being over 1/8 of an inch. Now, this VWAC gauge has 2 holes in it. And, you stupid thing, get out of my way so I got a mouse. One of those things. Okay, you see those 2 little holes right there. The bottom one is 1/8 inch pour. No, I mean, that's a 16th inch pour. The glare got me. And the top one is 1/8 of an inch. Now, we take our 16th, and we see that pour is too big. Go over the 1/8 inch, and if you can go to the very bottom, you have to scroll up a little bit, it's closer to a 3/32, so it is rejected. And the answer explanation is on per 5422. Stop rocking, please. Any imperfection must be 1/8 inch or less. Just a moment here, guys. I gotta reach in here. I am sorry about that. That hurt. 1/8 inch or less in size. If half of the specialized wall thickness is less than 1/8 of an inch, then the imperfection must not exceed that size. In this case, half of the wall thickness is 3/16 of an inch, so it has to be 1/8 inch or less in size. This imperfection measures slightly more than 1/8 of an inch when using the 1/64th measurement on the 6th scale. So they are showing you using this. So the 1/6 scale. I don't have a 1/6 scale on this. I have an 8. I have a 9. I don't have a 6. but using the VWAC works just as good when you're trying to see the holes. So if you go to the bottom, scoot up, there it is. So yes, the bend test is rejectable due to that 1/8 inch. To number 36 here. See where I'm at time-wise. Yeah, I need to scoot this up a little bit. And examine bend test specimen number 4 using structural steel. Did I just do that? Oh, Hades. I don't know if I went forward or not. Oh, yes, I did. Okay, 36. Okay, sorry about that. Examine the bend test B4 using structural steel acceptance criteria. Is this bend acceptable? So we went from B3 to B2 to B4. So you're looking at it, you see the grips. You're not seeing anything horrid on this. So the possible answers are no. There are total sum of discontinuities is over 3/8 of an inch. Well, there's no holes in it and everything else, so that's not it. No, there's a visible lack of fusion. No, it's all fused. No, the corner crack is more than 1/8 of an inch. There is no corner crack. Yes, the corner crack is less than a quarter. Again, no quarter crack. Yes, there are no discontinuities over 1/8 of an inch. Now, if you look at number 4 right here, you can see there are no cracks. There's no pits, no holes, no nothing. So, in my opinion, besides it not being bent far enough, it's good. And just one moment here, guys. That should be warm. One is cut. I flipped it over so it's in the moisture and everything else, and there's green beans.
Okay, it's past my. I know. Thank you.
You and your fasting.
Yeah. Also, that microphone doesn't really work.
Well, it's been working for me.
Well, it doesn't work for me. Anyway.
Huh. Okay. Oh, hon.
Hmm.
Did you know they had an on-off function? Okay.
I tried it.
It's
Not work.
been okay for me when I'm doing it, so I've been testing it, making sure our voices are coming through. Yeah, I'll just have to get a new one. What do you expect? I got this used. Okay, this one is a weld symbol. It has the arrow down this way with 7/16 with a groove, and in the tail it has PT, so we know that is a penetrant test. So the it says illustration number 6. How should we assess the T1 weld? So we are done with these two at the moment, and we're off to. Oh, and when you sign up for the American Welding Society, they send you books, apparently. I thought it was all digital now. I got a book. Oh well. Oh, anyway, so this is our T-joint item. We can kind of see everything on it. You have how everything is, and you have the letters up there for E for edge, T for T, and L for lap. So so every place is going to be different for the like the kit and everything else. So I'm not going to say what I paid for this, but getting the tools that you need, sometimes you just don't quite know. And they say, here it is, and everything else. And yes, I did expand a little bit on my tools and everything else, but again, I can't use one of them. I can use it in the field, but I cannot use it on the test. And that's fine. I didn't expect to. I wanted it for a field item anyway. So he says the T1 weld of the T-joint weld replica for compliance with this welding symbol and structural steel workmanship acceptance criteria. Assume this weld is for a statically loaded non-tubular connection. So we're going to look at T1. So we look at T1. It's the one with the big bubble on it, which is spatter. So our 5 possible answers are termination unacceptable, weld size unacceptable, spatter unacceptable. Termination unacceptable, weld size unacceptable, spatter unacceptable. Termination unacceptable, weld size acceptable, spatter acceptable. Unacceptable. Termination acceptable, weld size unacceptable, spatter unacceptable. We have termination unacceptable, weld size unacceptable, spatter unacceptable. So, oh yeah, that hurt. I was hoping that video would be done by now. I have I'm trying to upload the first video, which went through 1 through 22 with me on the microphone and everything else, as doing live was not working. I do a 2 hours, an hour and a half stream and only get maybe 30 minutes. So I'm trying it this way, and this way doesn't work. I don't know what to do. That's the best way to put it. So, the answer explanation is the termination of the center of the weld is unacceptable since this isn't a lap joint. The weld legs are barely acceptable per row 6 of table 1. And we look at table 1, row 6. Table 7. Table 1, number 6 is undersized welds. The size of the fillet weld in any continuous weld may be less than the specified nominal size L without correction by the following amounts. And then it gives it its sizes. But the weld throat is undersized at the crater. The spatter is not acceptable per section 2.2.3 of the BOS. So, as we look at this, is the termination acceptable? No, as it leaves a undersized layer of weld and a crater. Termination acceptable? It's saying yes, but barely. And in most of these cases, it's the size of the weld. Weld size unacceptable? Yes. But the termination was okay. Then the spatter is unacceptable, hence that big old BB right there. So the answer is D. Another one has the same style of weld symbol, instead of it being 7/16, this one's a quarter. And it's Cynically, so cynically loaded non-tubular. So see illustration number 7. I'm not sure. I'll determine it's illustration number 7, to be honest with you. Except for this. How should we assess the L4 weld of the T-joint? Weld replica for compliance with the welding symbol and the structural steel workmanship acceptance criteria. So let's go ahead and look at the L4, which is this one right here. This weld right here. As you see, there is some spatter. The weld itself is 3/16 of an inch on a 1/4 inch plate. So our 5 possibilities are, and each one is facing 3 different criteria. Weld size acceptable, porosity acceptable, weld termination acceptable. Weld size acceptable, porosity acceptable, weld termination not acceptable. Weld size acceptable, porosity unacceptable, weld termination unacceptable. So, weld size acceptable, porosity acceptable, weld termination unacceptable. Weld size acceptable, porosity unacceptable, weld termination acceptable. Now, if you see those 3 little dots of porosity, you know as just by looking, the combination is over the 1/8 of an inch. So we know it's not that. We know that the porosity is unacceptable. If it was just one of them, it'd probably be okay as long as it wasn't too big. But combined in 1 inch is too much. We look at what the explanation is. It says per row 6 of table 1, the weld can be undersized by 3/32, so the weld size is acceptable. Now this is where you get your fillet weld gauges. Look for the 1/4 inch or 3/32. As I do not have these organized, so it's going to take me a moment. Oh, 3/16. So if you see it here, you go across. You see that it's the 1/4 inch plate. We have 3/16. So we know it's not that one, so we go to our 1/4 inch right here. And what you try to do is match up the line, which I believe is like right about there. And that's how you're going to gauge it. Now, if the 1/4 inch, if it went all the way up and up into the gully here, then that would be a really bulgy weld. But you also have the 1/4 inch for a convex. Convex, not concave, not convex. So you have that. You have that possibility too. These are very, very useful. So we have the weld size is actually acceptable as it meets the criteria. We see the porosity is unacceptable, and the weld termination is unacceptable. If you look at it, it's too close to the corner. Either go up and around it, or go a little bit further back. But you cannot be that close. Also, if they would have stopped and filled it in a little bit better, that would have been nicer too. As these are all actual welds. These are the actual replica welds. So I'm sure somebody had a lot of fun doing this on purpose. So go back to the explanation. I did why the weld is, but since this is a cyclic fillet weld, line 8B of table 1 states the frequency of porosity on fillet weld shall not exceed 1 in each 4 of the weld length, and the maximum diameter should not exceed 3/32. Exception for a fillet weld connecting stiffeners to a web, the sum of the diameter of the porosity shall not exceed 3/8 of an inch in any linear inch of the weld. So it's 3/32, so it's a little over an 1/8 of an inch, but you do get the idea. The porosity size is acceptable. But there is more than one porosity within the 4 inches of weld, so the porosity frequency is unacceptable. Hence the per section 2.2.4.2 on the BOS, the weld should be terminated by wrapping it around the corner. And if they did that, they would have ran right into another weld, which would have been fine. Basically, wrapping it around and meeting the other weld, that pretty much would have completed how much you can go, because it's 4 times the height of the weld, I think it is. It possibly could be question on this. If it's in the book here of questions, I will end up talking about it, but I cannot remember the top of my head right now. So it's C. Weld size acceptable, porosity unacceptable, weld termination unacceptable. Number 39 is refer to the plastic weld replica T4. So we have this one. Examine the T4 weld of the T-joint weld replica. Does this weld meet structural steel acceptance criteria? Assume it is specified to be 5/16 of an inch size, and this is for a static connection. So, I'm going to take a look at this. You can tell it has multiple welds on it. Some spatter, but that spatter is actually weld strikes. So that's a no-no. Overlap. Oh yeah. Alright. So let's go ahead and take a look at what it says here. It says no due to overlap and arc strike. No, the size does not measure 5/16 of an inch. No, the undercut is excessive. Well, there's no real undercut. There's a light bit, but it's not much of anything. Yes, the size is acceptable. Yes, the porosity and overlap are acceptable. Well, arc strikes, overlap, those are two pieces that are unacceptable. So the answer is going to be A, no, due to overlap and arc strike. Now, the weld exhibits overlap. This is the explanation. The weld exhibits overlap, which is prohibited by section 2.3.1.4 of the BOS. So it exhibits arc strike, which is prohibited per section 2.2.2 of the BOS. Otherwise, it meets size requirements of row 6 in table 1 and does not exhibit undercut porosity. So, no. So if there's undercut, it's so small that it can't be measured, and there's no porosity, but there is the overlap and the arc strikes, so that immediately strikes it out to a re-weld. Our next one, 40, is examine the L2 weld of the T-joint weld replica. What is the best assessment of the weld if it is specified to be 3/16 of an inch in size? Let's go ahead and take a look at L2. That's this nice long one right here. Possible answers are: the size is acceptable, but the profile is too convex. The size is acceptable, but the profile is too concave. C, the size and profile are acceptable. D, the size is too small, but the profile is acceptable. And E, the size is too large, but the profile is acceptable. So let's look at the size and profile. Well, normally when you gauge something, you go down to the smallest piece of the weld, which is right here. That is the smallest part of the weld. And that's in right at like 1/8 of an inch. And you're looking at 3/16 of an inch. So it's still within that 3/32 tolerance. So it technically 1/8 inch. The rest of it is fairly good. Not really seeing just maybe a glimpse of undercut. Nothing to hurt anything. So I would say the size and profile are acceptable. And the answer explanation states, per line 6 of table 1, this weld can be as small as 1/8 of an inch in size. It measures at least that in all places. Excuse me. Sorry. A little gut problem here, unfortunately. The weld profile does not violate figure B or table 3 in the BOS. So table 3, let's see, that's right there. So schedule A, thickness. Table 3, schedule B. Second one, 5/16. 5/16 to 1 inch. As it's saying, it's 3/16. So we go to less than a 16th. C max or crown max is a 1/16 of an inch. So with it being over the 1/8 of an inch, we're golden. So let's see, size and profile are acceptable. Next, number 41. Let's see, L3A. L3A. There's B and A. And you'll notice that some of these are kind of hard to read by the stamp, but it's just, especially the pipe. The pipe is one of the worst ones. Examine L3A on the T-joint weld replica. How should the termination of this weld assessed using structural steel acceptance criteria, assuming the specified weld size is a 1/4 inch and it is a cynically connection? I cannot say that word with a darn. Cynically connection. Excuse me. The weld termination is acceptable. The weld termination does not wrap around the corner enough. The weld termination has more wrap around the corner than necessary. The weld termination stops short of the corner a sufficient distance. And E, the weld termination is too far away from the corner. Now, by this being a 1/4 inch, I believe you can go 4 times the size. So what's 4 times a 1/4 is 1 inch. The minimum is 2 times, so 1/2 inch. Per section 2.2.4.2 in the BOS, the weld should wrap around the corner at least 1/2 inch and no more than 1 inch. When measured from edge of the base metal, the wrap is less than 1/2 inch. So you look at L3. No, you look at L3A. You see how it just goes around and then it wraps. That's not enough. That's like a 1/4 of an inch. It needs to be longer. So the answer is B. The weld termination does not wrap the corner enough. Question 42. Refer to the upstream end of the pipe replica. So we'll take this one and now what I mean by that, if you can see that, the numbers on top, some of them are kind of hard to read. So you just kind of bear with. Some of them are double stamped, so you get that nice little blur in there. So the upstream end of pipe replica between markers 2 and 3, would this joint be acceptable per document 2 of the BOD? So we'll go to document 2. Okay. Excuse me. Now we're looking at the up end. So this should be the up end with the numbers right on the top. We look between numbers 2 and 3. That's exactly where the PO is. Now it's asking, will this joint be acceptable per document? So we don't have to deal with root spacing. We do have to deal with the top. So we grab our caliper. We go out between 2 and 3, so we have 2 and 3 here. Go out, so let it in. Pull it off. It's 3/32. Yeah, I was in the right one. It's 3/32. So it does match within that. Excuse me. All right. Just double checking here. Yeah, 3/32. It's 3/32, so it's over the 1/8 inch that they call for in the drawing. Sorry, I got ahead of myself there. I forgot to tell you what the possible answers are. Root face unacceptable, edge shape acceptable, wall thickness acceptable. Root face bad, edge shape bad, wall thickness good. Root face good, edge shape good, wall thickness bad. Root face acceptable, edge shape bad, wall thickness bad. Root face bad, edge shape bad, wall thickness good. So we've already determined that the root face is acceptable to a point. It's the edge shape that is unacceptable. We can have this nice little root face right here, which is just fine. Okay. Root face here would be just fine. It's this edge right here that is unacceptable. It needs to be 16th to an 1/8 of an inch. It is 3/32. Just a hair over. Then we have the wall thickness. Wall thickness. 2 and 3 is 11/64 and come on with that. She's doing math here. I have my fractions back here. Let's see here. So it's right between 5/32 and 7/32. Because this thing is 0.715. So we look at that. Wall thickness is unacceptable, as it is actually asking for room space, mismatch. Thickness range is 3/16 to 2.5, and it doesn't match it because it comes in like 5/32, so it's just a hair under. And so we're going to go with D. Root face acceptable, edge shape unacceptable, wall thickness unacceptable. And the explanation is the upstream end of the pipe refers to P4. Between the marks 2 and 3, the root face measures falls within the acceptable range. The root face measures falls within the acceptable thickness of 1/16 to 3/16 per WPS. However, the shape of the edge does not comply with the rest of the joint requirements, and the wall thickness of the location that is less minimum than 3/16, which is allowed per WPS. Did I make sure the wrong? Yeah, I had the wrong end of the pipe. This is where I don't read the bottom because I'm still testing myself. So if we actually went right there, let me get that would be a 9/64. So that's where that root face will come in acceptable. But the prep itself is better. It's the here. 2 and 3. No, let's do it this way. So if I can go this way right here, hit 0, go out, bring it back in. It's 1/16 of an inch. So that 16th is part of that root, helps with that root face a little bit, and so it's acceptable. Yay, I feel special. 43, as it's 10:23 right now, so getting a little late. Examine P3 well the weld replica between marks 3 and 4. How should this weld be assessed using pipeline acceptance criteria? Assume the width of the original groove was 3/4 of an inch. So let's go and look between 3 and 4 on P3. So here's 3 and 4, P3. So we see a little undercut. We see a gouge that looks like from a grinder. Some spatter. So let's go and take a look at our questions here. Weld face unacceptable, spatter unacceptable, weld repair unacceptable. Weld face acceptable, spatter unacceptable, repair unacceptable. Weld face unacceptable, spatter acceptable, repair unacceptable. Weld face acceptable, spatter acceptable, repair unacceptable. Weld face unacceptable, spatter unacceptable, repair acceptable. So we look at the weld face. Yeah, it's acceptable. The spatter is not, with all the little blips and everything else. It's not going to be acceptable. And the repair looks acceptable. It does not gouge into the metal. It's flush, and it's not taking away much of any type of reinforcement. So we look at the explanation. At this location, the weld face measures between 3/8 and 7/8 of an inch, which is allowed per section 316 of the BOS. The spatter is not allowed per section 317. The grinding repair makes a smooth transition and does not exceed the external reinforcement, so it complies with section 3.194 of the BOS. So B, weld face acceptable, spatter unacceptable, repair acceptable. Excuse me. 44. Okay. Examine the P1 gap at marker 1. Okay. So we have this right here. Examine the P1 gap, marker 1, assume an unaccompanied WPS rule allows an 1/8 inch plus or minus 32nd inch, and the pipe ends are same nominal thickness at this joint acceptable per pipeline requirements. So really, you're going to go, whoop, zero. You're essentially going to go like this. So in fractions, it's a 9/64. We'll go back to the very back where I have a chart that gets everything broken down. Once I find it. Here it is. Anyway, bit 9/64 is 1.40. So it does not seem like it would, but the offset is where your high-low gauge comes in. So let's go ahead and take a look at that. Let me reset this here to my face. Okay, make that firm. Let's take a look at our offset. back here. Let's see here. That one's up. That one's up. Tighten. We break it down. It's pretty close to a. Ow! Corner that laptop, that desktop. Just a little bit off of a 32nd. So at this location, the root falls within the allowable tolerance. The offset does not exceed the maximum 1/8 inch per section 313 of the BOS. So offset acceptable, root gap acceptable. Just 2 questions to go. Okay, now we're going to P2. Section 4. Right where the seam is. How should this well be assessed if used in pressure piping section criteria? Assume the wall thickness is a 1/2 inch and the design temperature is at 350 degrees. Alright then. So possible answers are undercut, bad, reinforcement, good, porosity, good. Undercut, good, reinforcement, bad, porosity, bad. Undercut, good, reinforcement, good, porosity, bad. Undercut, good, reinforcement, not good, porosity, good. We have undercut, good, reinforcement, good, porosity, good. So we're going to take a look at P2 Mark IV. We see some porosity spots that are over the eighth inch, but the reinforcement is high enough that it probably will not affect it. So if we look at the explanation, it says at this location the undercut does not exceed the maximum 1/32, which is allowed by section 4.2.2 of the BOS. The reinforcement does not exceed the maximum level of 5/32. So if we took this here, our high-low, do it here, go section 4, oops. There we go, section 4. Go down on it right here, close it. No, just go by the basic math. 1, 2, 3, 4, 5. Oh, weird. Sorry, must be biased here. Is how should the weld assess the pressure piping here? The undercut is acceptable, the reinforcement is acceptable, and the porosity is acceptable. The porosity at this height has to be, if I remember right, at a 530, no, like a 332, and it's just like right there. So that's gonna be good. Examine P1 near marker 4. So, how should this weld be assessed if using pressure piping assessment criteria? Well, we're talking about a tack weld. So the possible answers are reinforcement thickness is acceptable, the linear indication measure is about 1/8 of an inch, it's correct, it's undercut, it's acceptable, the weld has not been correctly prepared. And if you look at it, this one right here, on the side possibly, you can tell it's a thick tack. It has not been shaved down, so it is not prepared to go in for a full weld yet. Because you don't want these nice thick tacks, because you're trying to do a nice root bead. And when you have a tack, you go over it. When you're welding it, you can also help push it in, so it makes a little bit stronger of a root. And the answer is this tack weld is not considered complete or ready for final inspection. Therefore, it has no reinforcement or undercut. There is no visible cracks or linear indications. However, there is no apparent grinding or other Mechanical means of preparing that this requires for a smooth transition into the final weld section per 4.1.1 of the BOS. So, the weld has not been correctly prepared. Well, this ends section 2 practice test. So I know it's an hour and a half, yeah, there's the wife. Yeah, as you've seen her back there doing her little thing and stuff, does not transition from the screen to screen. So I hope you guys have enjoyed this one section. As I finish this test, I will do more on the other 2 tests. As I'm going through those, I have written all those questions down too. They make you go through A and C first before you even practice B, so you can understand and try to find all this information. And when you got a book like that, and I have not shown you yet, it's in my bedroom, it is one mean MFer. I mean, it's so much knowledge in that little book. When I say book, 600 pages, I guess is, well, for what the wife reads, it's small. She likes these 1,200 page books. She just reads them in like 3 days. It's done, if that. So, and she can retain it all. That's the sad part. She can retain all that information, how it's done. And it takes me 6 months to do this. So you can see where the brains of the project here are. But yeah, I hope you guys enjoyed this. I will see you guys on another video, and I will have this. The next one's uploaded here, I'm hoping in the next week or 2 as I go for my test next week. So until then, learn a lot, retain, study, have fun.